the molar mass, or the gram molecular weight, remember, you might see whatever kind of wording here. There's molar mass, gram molecular weight, gram formula weight, gram molecular mass, gram formula mass. Just remember that they all mean you're doing the same thing. Here's where people get kind of screwed up. There's two places people get screwed up with this. Number one place where people get screwed up is when they see it written like this. They see the formula written out. They forget that there are 3 nitrogens. Okay, so nitrogen, there's 3 of them. And the molar mass for that is 14 grams per mole. There are 3 times 4, there are 12 hydrogens. So there's 12 hydrogens, and that's 1 gram per mole. And remember, these numbers right here, all of these numbers I'm getting come from your periodic table. And it's always acceptable to round. You don't want to round chlorine. You want to keep it at 35.5, but it's acceptable to round the numbers that I'm rounding right here. Okay, phosphorus. You've got 1 of these. You do not have 4. You have 1 of them times the phosphorus is 30.973, so it's very okay to go ahead and round that to 31. And then oxygen, we've got 4 of them. 4 times 16 grams per mole. Multiply those numbers out. 3 times 14. 42. 12 times 1 is 12. 1 times 31. And 4 times 16 is 64. So remember, you're going to add all these together. So you got 42 plus 12 plus 31 plus 64 means that's 149 grams per mole. So in other words, the way that we would read that, we would say 1 mole of ammonium phosphate has a mass of 149 grams. That's what that means. Okay, so number one mistake that people make is that they forget to multiply outside the parentheses. Okay, so there's 1 nitrogen, and they forget to say 3 times that 1 right there. Or another mistake that they make is that they see the 4 here on the PO4, and they'll say they say 4 phosphates, 4 phosphoruses. You do not have 4 phosphoruses. You only have 1. Okay? So you got 3 times 1 is 3 nitrogens. 3 times 4 is 12 hydrogens. 1 phosphorus, 4 oxygens. Now let me tell you the second mistake that people make. When you're reading a formula, okay, like this is a common one that you've had, N2 plus H2 is going to give you 2NH3. Okay. So now remember, these numbers here, these are moles. Your coefficients are moles. I know I didn't spell it right, but you can figure it out. Are moles. So that reads 1 mole of nitrogen gas plus 3 moles of hydrogen gas give you 2 moles of ammonia. Okay? Now, another mistake that people make, there are several mistakes that people will make with this, to be honest with you. So the coefficient here is a 1. The coefficient here is a 3. The coefficient here is a 2. A lot of people want to include the coefficient in the gram molecular weight or the molar mass. Okay? Do not include, so if you have an equation and you need to know what the GMW is, or the molar mass is, for something in your equation, do not include the coefficient in calculating it. Okay? So, for ammonia, NH3, your molar mass, you've got 1 nitrogen, so that's 1 times 14. You've got 3 hydrogens, so that's 3 times 1. The molar mass is 17 grams per mole. Okay? It is not 2 times that. Okay, so ammonia is 17 grams per mole. It is not 2 times that. Okay, here's another thing. Remember, these are diatomics. When you do a molar mass, or a gram molecular weight, gram formula weight, GMW, whatever you want to call it, when you're doing diatomics, okay, the GMW for N2, you have 2 nitrogens. So you say 2 times 14, and that's 28 grams per mole. You have 2 hydrogens in H2. So you say 2 times, 1 is going to give you 2 grams per mole. So it's a simple concept, but once you put it into an equation form, and you know that later on in your equation you're going to have to be doing gram formula mass, gram conversions, whatever. Don't make the mistake. Number one, do not multiply your coefficient to find your GMW. Do not do that. Number two, if you have a diatomic involved, you have to take the subscript here, because what this is, these 2 nitrogens, they hang out together, and so they count as a particular unit. They're molecules. They are not individual atoms. Okay, so it's 2 times that. Same thing for hydrogen. They hang out together. That's one little molecule now. So 2 times that.